Moshi. Let's talk about the future. I'm Christy Bird McKeeve, the host of Evergood podcast, where we talk about healthcare education innovation. It's a broad tent, and today I'm excited that we'll be looking at research in medicine, medical research, and when I introduce our guests, you'll get a better idea of the topics that we'll be covering. So thank you so much. Robert Green, MD, MPH, is joining us today, and he is a medical geneticist and physician scientist who directs the G2P research program in translational genomics and health outcomes. It's a division of genetics at Brigham and Women's Hospital and Harvard Medical School. And he is a principal investigator of the NIH-funded REVEAL study. We'll be talking a lot more about the different projects that he's involved with, the Baby Seek project, for example, and a recent TED Talk. Really excited to share that with everybody. He is also currently the Associate Director for Research of the Partners Center for Personalized Genetic Medicine, and so much more. I feel like I could go on and on about your introduction, but I think we should just dive into what the heck do you do? No, just kidding. And just really talk about this April 2025 TED Talk, which explains the latest work that you've been, well, you do a lot, but this is one area that really does help people. And I wanted to note it's called The Life-Saving Secrets in Your Baby's DNA, recorded through TED 2025 in April 2025. So thank you so much for joining us.
Well, thank you, Christy, for having me. I'm delighted to chat with you.
So let's talk about the research that you do. It's very broad, but especially leading into the TED Talk work.
Sure. So people think about research with test tubes and microscopes and animal colonies and petri dishes, and all of that is sort of discovery research. I do a much less exciting type of research called implementation research. So if you've learned something that might benefit human beings, how do you get it into the medical workflow? How do you get it out to people? And it's broad. It encompasses not just conventional medicine, but very curious about societal implementation. What kind of policies or legal regulatory structures make for better health, and which ones keep privacy intact, and what do you do with newborn babies, and what do you do with adults, and what about companies that have consumer facing products? So it's really all of that. And my particular niche has been genetics and genomics. And what I mean by this is the science of your DNA. And if you had to pick one theme that has really been the thread that connects my research over the last 20 years, it would be the thread of DNA first. Whether you're talking about adults, whether you're talking about research situations, whether you're talking about newborn babies, what's the benefit and what's the harm of using their DNA to understand what kind of conditions they're at risk for and how you might offer them better health? So that's the thread, DNA first. And where that thread is most alive in the world right now is the notion that newborn babies could have their DNA looked at immediately after they're born.
Hmm.
And with consent, with appropriate privacy protection, of course, their parents and their pediatricians could be alerted to treatable conditions right at the beginning of life. And we have postulated, and we believe we have created some evidence to support the notion that this could benefit all of humankind. And that's really what my TED Talk was about. It was about the very first times we did this back in 2012, 2013, 14, 15, the resistance that we got when we first did it, and how it's catching on all over the world right now.
It is an interesting, I'm a mother of two, and I was putting watching the TED Talk, I was putting myself in the place of a mom with a newborn baby. And, but I do have an understanding of the fact that we may be having healthy babies, but what we don't know is what's happening inside their bodies later on. And I think the TED Talk really dives into the number of diseases that exist and can be told by the DNA, but that might not be noticeable until later on in life. And also struggling with family members right now on diagnosing dementia, mental health issues. It's really hard. And if I could have that DNA that tells me, this would be where those, dementia, mental health issues might be living, would be so helpful for my family members. Yeah.
Yeah, it's really helpful in a subset of conditions. It's not going to be helpful for everything.
Right.
And I would say that mental health issues are one of the areas where genetics doesn't inform us a huge amount at the moment. Maybe on some of the treatment areas with which medications to use. There's some pharmacogenomic insights that may be helpful.
Right.
But the big areas that genomics can be helpful in adults is screening for cancer predisposition and heart disease.
Yeah.
A subset of those conditions are inherited, strongly inherited, and whether or not you have a family history or not, you can detect some of those markers in the DNA,
Yeah.
and you have more choices when you know that you're at risk for a particular type of cancer or a particular type of sudden cardiac death, for example. That's in adults. Now, in babies, the situation's a little different. There's 10,000 or so rare diseases, some of them super, super rare, and nobody knows them all. And some of them present early and are obvious when a child is born, but many of them are not obvious at all. They come on slowly or later. Pediatricians have never seen them before. Families go through what's called a diagnostic odyssey, which can last years with a great deal of distress, uncertainty, confusion, and expense. And ultimately, a diagnosis is made, at which point it can be treatable or untreatable. But the treatable ones, the child may have already lived through the most appropriate period for treatment. It might be too late to treat them. Even the untreatable ones, when you talk to families who have these rare disease children, they almost inevitably, not 100%, but they almost inevitably wish they had known earlier what was going on, because the uncertainty of what was going on in their child was so absolutely terrifying, upsetting, consuming. So we're really moving from a world where we've been afraid of genetics, afraid of DNA, or seen it through as a crystal ball, or being super worried about privacy invasion, to one where those issues are still relevant, but it's we're moving to a world where more and more genetic conditions are treatable, truly treatable, maybe even curable. And that's a whole new world where DNA first is going to be super important.
Yeah. Such as like pancreatic cancer too. I'm thinking it's really hard to diagnose and it develops over time, and there is no treatment for it that I know of at this time. Um, and knowing that you're predisposed to some of those cancers would be amazing. Yeah. I'm glad
That's right.
we're talking too about just this public acceptance, if that's the right word, right? Where it's kind of like the science is there, and then you're in the space of really sort of making that more commercialized and available. But it really does take the public accepting it.
It really does. And it takes the medical system accepting it.
Ah,
Right now, there's very little reimbursement for anybody who would want to go out there and say to their doctor, "Hey, I'm interested in what's involved in my DNA. Can you check it for me?" And it's not that expensive to look at the most common condition for the most common conditions, a couple $100, but there's no reimbursement for that from most insurance companies.
yeah.
So For example, one of the companies I work with, called Genomic Life, is making this available through employers, which is a clever way to make
Ah,
such resources available to people. So,
that's-
in that model, your entire company can say, I'd like to make this option available to my employees. They sign up for it as a voluntary benefit, a small amount per member per month, and then they have a choice if they would like to get themselves tested for predisposition to cancer, predisposition to heart disease, or some of the other conditions we're talking about. So there are a lot of interesting and creative models evolving that go beyond just butting heads with the insurance companies over
yeah.
their historic their historic unwillingness to fund preventive strategies.
Yes. And what we started off this conversation talking about streamlining diagnoses and giving those tools that are now developed and could be applied. Wouldn't wouldn't there be an incentive to streamline the diagnoses by the insurance companies, right? They could have more money then to uh, do the treatments that are needed for certain diagnoses. It seems a little
There,
bit at odds
yeah,
with
there.
everything.
Well, there absolutely is a vision of this where society as a whole saves money. So if you get the right recipe of screening tools, now we're not just talking genomics, but all sorts of screening. You get the right recipe, and you find conditions early, and you treat them early before they become more complicated and complex and severe. You may be able to save over the lifetime of an individual. You might be able to save on healthcare costs writ large. That's the vision of preventive medicine in general. The problem in the United States is that insurance companies often follow people for just a year or two or three, and therefore the benefit of detecting things early may not accrue to that insurance company because it might take 5 or 10 or 15 years for the financial benefit to accrue. So the way we've set up reimbursement in the United States does not readily lend itself to long-term prevention. It more readily it can benefit short-term prevention, like cancer detection in your body, but it may not lend itself to the idea that, oh, let's check your DNA and we're going to find out several things you're at risk for over the next 40 years, and we're going to enact some surveillance and some modifications in your medical care. Your typical employer-based insurance, which churns every 2 to 3 years, is not going to see a financial benefit from that.
You make a very good point of, and yeah, there's not. Does anybody have a lifetime of healthcare with one facility and one doctor? No, like it just doesn't happen anymore. And I think, yeah, we've built everything on that premise, but it's not actually true. Um, I wonder if we might. I don't know. Do you want to talk more about the downstream effects or costs of the
Well,
research that you do?
I will say that there are countries that have a single payer system, like the United Kingdom, and they are more aggressively pursuing population genomics. And it makes sense for them because if they can r- catch things early and cure things early or manage them better before they get severe and costly, you could see a future in which this actually reduces costs. Um, Genomics has come down in price enormously. The very first genome famously was sequenced for about $3 billion, and a typical clinical quality genome can be done today for $400 or plus or minus $100 with a little bit more for interpretation, depending how much you're interpreting. We're definitely dropped below the $1,000 genome at this point. So we're in a world where this is becoming potential for mass utility. And I just got back from London, where we had the fourth annual meeting of the International Consortium on Newborn Sequencing. And when I started this with my co-founders 4 years ago, we we only knew of 8 programs in the world that were doing this, and we started it with those 8 programs. And we are now over 30 programs in the world and over 700 members of this consortium that are trying all sorts of different models for newborn or early childhood genomic screening. So, it was such an exciting meeting, Christy, because we've watched the number of people interested, the number of programs, the number of countries expand, but we've also watched the attitude change from sort of, should this be done? Is this a good idea? Maybe it's dangerous, to not a cavalier attitude. It's still got a lot of questions to sort out, but a much more robust, enthusiastic interest from all around the world in this whole area, this area of starting life off knowing something about your genetics. So again, throughout this conversation, we're kind of talking about 2 domains. We're talking about what it would mean to start life with with some knowledge of what's in your genome, and then kind of separately, we're talking about, well, if you're already an adult, what could you still learn about your genetics that could help your health? So I want to keep those two. They're related, but they're kind of 2 different domains.
Yeah, I appreciate that. And always feel free to explain things so that our audience and myself can learn. I also, when I think about research in general, it really does drive medical medicine, but in also medical education. So, what might you want to share with somebody who's, maybe in medical school or thinking about medical school, and how would you want to see the work that you're doing being embedded in a medical education curriculum in every medical school?
Well, thank you for that question. That's what a great opening. Uh, there are a couple elements from my world that I think could be better emphasized in pre-med and medical education. First of all, whether we like it or not, it's a computational world. And whether you are talking about genomics or other parts of medicine, the ability to understand some basics in computer science, to understand computational programming, to understand large data sets, to be able to use AI are obviously going to be so important to the next generation of physicians, whether they and healthcare providers of all stripe, whether they are actually in patient care, research, policy, whatever you're in, you can't escape this. You just have to embrace it, and so that's writ large. Number two, uh, pre-med and medical school don't often emphasize what I do, which is implementation science. The notion that it's not enough to just discover something. It's not even enough to generate a treatment. It's not enough to hand that over to the pharma companies. You actually have to think about how you change the practice of medicine. What are the financial and policy incentives and disincentives? How you get things covered by insurance, how you protect patient information, how you share patient information where it needs to be shared. These are part and parcel of the healthcare ecosystem, and you cannot escape it just by kind of concentrating on your basic science niche or your drug niche or any of that. And then the zeroing in on the area I love, I do think there needs to be, I mean, this everyone would say this about their specialty, but I do think there needs to be way more emphasis on integrating genetics and genomics into every aspect of healthcare um, and medicine. And that starts with undergraduates. Frankly, it starts with high school and elementary school. It starts with undergraduate courses. You've got to get people past the simplicity of dominant, recessive, and X-linked into an awareness that we have lots of variable expressivity when you have genetic markers. It's a risk factor, more like high blood pressure or cholesterol, not a crystal ball for most genetic conditions. And you got to really change the mentality with which clinicians have come to genetics. The mentality today is, oh, let's refer this question or this patient to a genetic counselor or a medical geneticist. And there's just too much genetics for that to be the answer. We just as a You wouldn't have a primary care doctor say, I'm never going to treat a case of depression. I have to refer that to a psychiatrist. Or I'm never going to treat a case of elevated cholesterol. I have to refer that to a lipidologist. You wouldn't see that. These are too common. In the same way, we have to change the entire workforce to embrace at least the basics of recognition and treatment in genetics, and then appropriately use more specialized care for more complex situations. So those are the areas I would, if I'm talking to trainees or people who are in charge of trainees today, I would say computation, implementation science, and genomics have to be all three have to be much more emphasized than they currently are.
Um, Sort of like, so if they're talking about a disease, that those three things are sort of part of that whole discussion.
Yeah, any disease, I mean, every disease, I think it'd be fair to say every topic in the world is going to, at its most sophisticated levels of conversation, is going to involve large data and computational thinking.
Yeah.
Uh, any concept in healthcare has got to not only be developed in a vacuum or in a laboratory, but also attention must be paid to implementing it into the culture and the ecosystem in front of you. And to my specialty, genomics will not be the answer for everything, but genomics will be threaded through cardiology, renal, pulmonology, cancer, of course. Genomics is threaded through each and every specialty, uh, and psychiatry as well. Though, as I said earlier, perhaps at this moment a little less
Yeah.
focused in the area of psychiatry, because mental health issues, for the most part, are have not been Mendelian, meaning there's not a single gene disorder that accounts for depression or manic depressive illness or alcoholism or any of the major mental health categories.
And so that has been researched. Uh, right. So yeah,
Right.
to be
I mean,
very
yeah, we have to separate family history and things that run in families. It's well known that certain types of affective disorders can run in families. To some degree, schizophrenia can be more common if there are relatives, but they are by no means dependent on a single gene, which
gotcha.
is sort of how we start when we think about genetics. Now, there's a whole relatively new area of genetics called polygenic risk scores, which does not depend on a single gene, but which adds up tens or hundreds of thousands of markers from all across the DNA genome in your body. And you can get some degree of risk prediction for many common disorders, heart disease, common cancers, atrial fibrillation, type 2 diabetes. And some of the psychiatric syndromes can have a little bit more of a genetic predisposition. So you can start to measure that. But those are risk factors. And we have to shift our mentality to see those genetic polygenic risk scores as risk factors and not deterministic.
Yeah.
There are entire companies these days that are, I think, deliberately letting people be misinformed about polygenic risk scores, and they're using them for embryo selection. They're using them for, they're claiming more relevance than they have. And I think we just have to educate the public so that they understand that these are valid risk markers, but they're modest risk markers.
Gotcha.
And they shouldn't really be used at this point in time to as the kind of predictors that you'd necessarily want to say rank embryos with.
Yeah. Skipping back just a little bit to where you were talking about the healthcare infrastructure, just a quick question that popped into my mind is, like, does Epic and EHRs have a section for genomic testing? And is it easy to find? I don't know. I'm married to an
Yeah,
internal medicine doctor, and he works at Kaiser, and they're working on a dashboard where, instead of having to go through the whole entire patient file, that AI can just help bring to the forefront. So it's good to know that at least the EHRs have that in place. Is that what you're nodding your head? Yes. Yeah.
they do. Yes. Epic in particular has a genomics module. Uh, it's been gradually improved over the years. Uh, it's been a bit of a challenge because there's a lot of data in the genome. And so you got to decide what you're actually going to put in place. And I can't comment on the details of the Epic module. I'm not that familiar with it, but my understanding is that they have gradually been improving it, and that more and more Epic clients are bringing that into their Epic instantiations. Yes, EHRs do need to learn to manage genomic information.
And it's more about the size of that data.
It's the
Not
size of the data, although when you have a huge genome, it does take up a lot of computer space. But most of the time, you've extracted what's called a variant call file, which is much smaller and has most of the information you're ever going to need for the health aspects of the genome. So it's not necessarily a big storage problem if you bring those variant call files into an EHR, or even if you've sent it out to a laboratory, the laboratory has done all the variant calling, and you just even want to bring a report into the EHR. I mean, you don't bring the when you get an MRI, you don't bring the MRI data file into your EHR. You just bring the report into your EHR. So you could imagine a parallel where you don't even have to bring the genomic information, the raw data, into your EHR. You just bring the report in. That's another model that people are exploring. And then the question is, okay, I'd rather bring it in a way that's more useful than a flat PDF. So how do I bring that in? And there's better minds than mine working on how to bring that in a dashboard type situation, how to integrate it with medical decision making and so forth.
Okay, so the leaf blowers are in full effect over here. So I'm just curious, what would you say to somebody who's interested in pursuing medicine? Maybe thinking about the future of that medical education journey and what would you say?
Well, medicine and healthcare in general is in a tough situation right now in the United States. We are spending a lot more than other countries. It is not always reflected in health metrics, so we're not necessarily spending it efficiently. And There's a lot of interaction between what they call social determinants of health, where you live, how much you make, whether you have access to good food, exercise, weight reduction, all those sort of things we think of as either environmental or lifestyle could make a huge difference if we had proper incentives in place to benefit people across the board. So, from a public health point of view, genetics is not typically the most important thing that would help the most number of people. But for those who are interested in genetics and genomics, like I am, I do think there is a public health benefit that is far broader than people realize. I do think that our research work has shown that if you were to look comprehensively at your genome and everybody who's listening, that a full 10 to 15% of them would be carrying a single gene risk variant. Now, think about that for a minute. Um, 10 to 15% of the American public across the board is carrying a genetic marker for risk of a single gene disease. Some of these are very dramatic, like BRCA1 for breast and ovarian cancer. Some of them we've never heard of, and they probably will never bother you. Many of them won't happen, but they're out there. Some of them might be around things like hearing loss. Would you like to know if you're at increased risk for a genetic risk for hearing loss? You probably would, because you might avoid rock concerts and working on aircraft carriers where there's loud noise that's going to damage your ears. Would you like to know if you're at risk for renal failure? Probably, because then you might avoid certain kinds of medications. So there's a lot of information out there that could be helpful and will be helpful in public health once we find ways of bringing genomics into everyday medical care. And this is not my idea. This is an idea that's been talked about for 30, 40 years and has been developed by some of the pioneers of genetics who have talked about precision and personalized medicine for years. I'm just fortunate to have found an academic path where I can be providing evidence to make this happen in the world. That's if you had to put me in a niche, that's what I've been doing. Implementation science to demonstrate to the world that yes, this is feasible, this is possible, it's productive, and it could be beneficial without tremendous catastrophic distress and without catastrophic healthcare costs. So sometimes I like to say that what we've been working on are three things: the medical, behavioral, and economic outcomes of genomic medicine.
Can you speak just a little bit to the behavioral side of that, which is, I think, what really would be stopping progress because of the fears and the concerns? And what have you found in the work that you've been doing?
Yeah, there are a lot of fears. They generally focus on a couple of themes. One theme is I just don't want to know. If there's something bad that's out there, it might happen to me or might happen to my baby. I just don't want to know. I believe in destiny. I believe in religion. It's not my place to learn. And I think people should have the right to choose, absolutely, whether they want to know something or not. We are seeing generational changes in that. I think younger generations are much more interested in information for information's sake, and they're much more interested in knowing something so they can try to do something about it in advance. So that's one fear. A second fear is if I'm told I have a risk variant for something, uh, or if I'm a doctor and I'm about to tell somebody that, they might get catastrophically anxious or depressed, suicidal. When I first started this work, people were convinced that we would create really life-threatening anxiety. And I would never be cavalier about the fact that when you're telling somebody something, it can be scary, but it has been remarkable over 15 years now when I've been bringing genomic information, unanticipated genomic information back to people in multiple contexts, returning it in research studies, returning it in population screening, returning it to parents about their children. It has been remarkable how modest the distress has been. Uh, People are realistic. They don't want to hear bad news that their child or they are at risk for something, but they quickly adapt and quickly move on to being appreciative of the information and then to acting on it. A third area of concern that you might call psychology or sociology is just general concerns about privacy. We are in a world where identities are stolen, credit card information are stolen, various things are hacked, uh, and genetic information feels very private and feels very personal. And the notion that this could be hacked by a bad actor is out there. It's true, it could be. And in a few occasions, it has been. But as I like to say, as I said in the TED Talk, um, if you get your credit card information or your identity stolen today, there's a lot that bad actors can do with that. At least today, and for the immediate future, if somebody steals your genetic information, there's not much they can do with it. Employers are forbidden by law to use it. Life insurance companies could theoretically use it, but they'd get tremendous blowback. Health insurance companies are not by law allowed to use it to charge you increased premiums. So it's a concern. I wouldn't diminish the concern, but I think people are forgetting to weigh that concern against what I've been trying to articulate is the benefits of the medical benefits of genomic information. I think we've got that balance out of whack.
Okay, well, I really appreciate your time. So if there's anything else that you wanted to add, or if we covered everything, there's so much more to cover, but anyway.
Well, I would say that for people who are interested in this area, you can check out our research website at Genomes Two People. That's genomes, the number two people.org. Um, you can check out the TED Talk, and there's material on the TED website about our various initiatives. We have a couple of companies that we work with and have started a company to sequence children. And that company is nurturegenomics.com. So if people are interested in those, I invite them to check those out. But I think the biggest message I'd like to leave people with is don't be afraid of what's in your DNA. I think in the long run, we'll look back at this time period where we're sort of getting accustomed to using genomics in healthcare, and we'll say, oh my gosh, why didn't we do that sooner? Why did we wait so long? What were people so afraid of? And this will become as routine in medicine as it is to weigh yourself or take your blood pressure or do a lab test of any kind. And I think I would encourage people uh, to move past their fears and learn as much as they can about genomics and ultimately about their own DNA.
That's a great vision for the future. Thank you so much. I'll make sure that all of this is noted in the episode paragraph, and I hope to see this future come to fruition.
Well, thank you so much for having me, and thank you for the time today. I've really enjoyed it.
Thank you.
Lost my sense of humor, I found them too fun to know. Overgrass, blow up kayaks would have helped with angry toes, but it gave mashed potatoes. Take that meatloaf back, hi. Birthday dehydrated cake and lots of wine, so nice with clean dark hair. think it's a waltz. I think it's a waltz. But I know it's the longest 2 miles of her. I think it's a waltz. I think it's a waltz. But I know it's the longest 2 miles of her.